Garbage in, garbage out is an old saying in computer science. If you have bad input, you can't generate good output from it. This is also true for measuring flicker. If you have bad measurement data, then you're not going to come to a good result. Measuring flicker is especially challenging if you have a light source that's dimmed by pulse width modulation, like you can see here where we have interference with a camera. The problem is that some test equipment on the market uses too low sampling rates. They are insufficient for measuring modern LED drivers, and good drivers can appear worse than they are. The Nyquist-Shannon theorem defines that the sampling frequency has to be at least double of the frequency of the signal to be able to reproduce the signal. When the sampling rate is too low, you get aliasing, which means the measured signal is not reproducing the actual signal. These two examples here show what can happen if you have a way too low sampling rate or just a little bit too low sampling rate. You get wrong frequencies or you miss pulses. Aliasing can also happen when the pulse-pause ratio of a pulse width modulation dimming gets too large. This example here shows what happens if you have a 1 kHz pulse width modulation at 10%. This already has frequency components of 10 kHz, which can be easily missed if you have one of the test equipments with really low sampling rate. Spectrum PWM is a real killer for flicker measurement equipment. It uses a pseudo-random system to spread its signals over a wide frequency range, and it's really hard to measure by the typical equipment. How can you make sure you're measuring no garbage? First, know the limits of your measurement equipment, and then always check the results for plausibility. If your measurement equipment tells you that there is a really low frequency part, have a direct look at the light source. You should be able to see that. Eliminate external interference like other light sources, and always remember, sampling rate can only be replaced by a higher sampling rate. Thank you for watching, and don't forget to like and subscribe and come back for more.